All right, welcome to this explainer. Today, we're diving straight into the ultimate rulebook of the universe. We're looking directly at the mechanics of force and motion interaction. If you've ever wanted a really structured, clear-cut understanding of exactly how the physical world holds itself together and interacts at a fundamental level, well, you are in the perfect place.
Okay, let's dive right into this. Matter literally never moves without a reason, right? I mean, whether it's a massive planet orbiting a star, a car taking a sharp corner, or even just the immense tension pulling on the cables of the Golden Gate Bridge, there's always a cause. It's absolutely never random. So, what are the invisible rules governing all these movements? Well, that's exactly what we're going to decode today.
So here's our quick roadmap for today. First, systems of forces. Then we'll build our toolkit with free body models, move into Newton's laws of motion, explore centripetal force, scale way up to universal gravitation, and finally, wrap things up with Hooke's law. Let's get started.
Section 1. Systems of forces, the overarching theme of physical interaction.
Basically, everything we're discussing today is driven by one core imperative: analyzing how pushes and pulls actually interact with physical matter. We're here to figure out exactly how these invisible interactions literally hold our world together. It's kind of the master rule from which every other physics principle flows.
Moving right along to Section 2, free body models, our analytical toolkit.
Now, before we can really master the rules of motion, we face kind of an interesting problem. How exactly do we visualize forces that we literally can't see? Since we can't physically spot gravity or tension with our own eyes, we have to rely on structured models to show us exactly what's happening to the matter we're studying.
So the crucial point is that free body models aren't just, quick, messy sketches to get the general gist of a force. No, they are highly precise visual tools. We use them to map out both the qualitative behaviors and the hard mathematical quantities of a system. They brilliantly bridge the gap between abstract concepts and actual hard calculations.
And listen, we don't just use these for simple, everyday scenarios. We have to apply them to forces in one dimension, like an object sliding back and forth in a straight line, and in two dimensions, where multiple interacting forces on totally different axes become a whole lot more complex. It's like a giant puzzle we get to solve.
All right, Section 3, Newton's laws of motion, explaining force interactions.
Now that our visual toolkit is ready to go, we're absolutely ready to tackle the first major set of behavioral rules. It's a very clear step-by-step sequence. We carry out investigations, we use those results to explain the interactions of forces, and then we directly apply Newton's laws to see exactly why matter behaves the way it does.
To put it simply, Newton's laws of motion are the foundational rules used to explain force interactions on any specific object. When we draw out those free body models we just talked about, it's actually Newton's framework that dictates how those forces resolve and how the object ultimately responds.
Let's move on and see how this builds in Section 4. Centripetal force in circles, moving in a curve.
When we shift gears from straight lines to curves, we run into centripetal force. Whenever matter moves in a perfect circle, think of a massive roller coaster navigating a loop or a satellite whipping around the Earth at a mind-blowing 17,000 miles per hour. This is the exact set of basic forces keeping it tethered to the center point. It's literally what prevents it from just flying off into space in a straight line.
And just like we discussed earlier, we're definitely not just guessing how an object curves. We construct models to analyze this circular movement, carefully calculating both its qualitative traits and its precise mathematical quantities to keep it strictly tethered.
Okay, Section 5, Law of Universal Gravitation, the cosmic pull. We are dramatically shifting our scale upwards right now. Right now, the law of universal gravitation is pretty much the ultimate interaction model because it dictates the invisible attraction between literally any two objects in the entire universe. We're talking everything from an apple falling from a branch all the way up to planets orbiting stars. Now, what's really interesting about this relationship is the sheer precision of the variables involved. We are modeling the relationship among three exact things: the force of gravity, the physical distance between two objects, and the mass of those objects. You change just one of these, and the entire cosmic interaction completely shifts. It's wild to think about.
And bringing it back down, Section 6, Hooke's law and elasticity, the power to bounce back. After looking at massive planetary gravity, let's bring things right back down to the tangible, everyday world. Hooke's law explains the exact effect of elastic force on objects. Whether it's a stretched spring or a bungee cord, Elasticity is governed by its own totally distinct set of interactions. It's completely separate from the continuous pull of gravity or that circular centripetal motion we saw earlier.
Because, we aren't just passively watching a ball bounce here. We are actively analyzing and interpreting hard data to prove these elastic effects mathematically. It is the ultimate scientific method in action, showing us exactly how materials compress, store up energy, and then just snap back.
Wow. Okay, we've covered a tremendous amount of ground today. From our basic analytical toolkit of free body models out to the far reaches of universal gravitation, and then right back down to the everyday elasticity of Hooke's law. So I want to leave you with a challenge. Take a second and look around you. Which of these invisible force models are acting on you right now? Because the mechanics of force and motion are absolutely everywhere, just waiting for you to analyze them. Thanks so much for joining me on this explanation, and keep exploring those invisible rules.